This video will connect a normal bell curve with a real-life example, the mean, and a standard deviation. The real-life example is the height of 3-year-old females. We can see from the histogram that heights of the 3-year-old females ranged from 29 to 48 inches, or the heights were somewhere between there, with the highest number of children having heights between 38 and 39 inches because that's the highest bar. We also notice that the normal bell curve has its peak also in that highest bar, and that should be expected with a normal bell curve. When the data was collected and the mean was calculated, the mean was 38.72. If we approximate its location, we can see that that is approximately where the height of the bell curve is, 38.72. The area under a bell curve has a sum of 1. So the area to the left of a mean is 0.50, or half of 1. The area to the left of the mean is 0.50, or 50% of the area. The area to the right of the mean and under the bell curve is also 0.50, or 50%. That means that out of all of the heights of the 3-year-old females, 50% of the children should have heights that are greater than 38.72 inches. Now let's take a look at standard deviations. The standard deviation was 3.17 inches. One standard deviation below the mean then is going to have a value of the mean, 38.72, minus the standard deviation of 3.17, to give us a value of 35.55. So the value for one standard deviation below the mean is 35.55, or halfway between 35 and 36 inches. Likewise, if I want to know the value for one standard deviation above the mean, I would add the standard deviation onto the mean and have a value of 41.89. It is helpful to know where one standard deviation below and above the mean is, because the percent of the population between those values is approximately 68% of the population, meaning about 68% of the 3-year-olds will have heights between 35.55 inches and 41.89 inches. Next, I'm going to look at taking more than one standard deviation below the mean. Remember, the distance between the mean and the value of 35.55 is one standard deviation, or 3.17 inches. If I subtract another 3.17 inches, I end up at 32.38. If I go to the right-hand side of the mean, where I had added the standard deviation, if I add another standard deviation, I end up at 45.06. So far I have subtracted and added 2 standard deviations to the mean. The area between the value 32.38 and 45.06, that area represents about 95% of the population. So about 95% of children age 3 that are females should have heights between 32.38 inches and 45.06 inches. Children outside of those ranges are considered children having unusual heights. Let's take a look at one more standard deviation below and above the mean. When I subtract 3 standard deviations overall from the mean, I end up at 29.21. That's 3 standard deviations below the mean. When I add 3 standard deviations to the mean, I end up with 48.23. The area between those represents 99% of the population, or almost all of the population. So 3 standard deviations below and 3 standard deviations above represents 99% of the population. When given a normal bell curve and the basics of a mean and standard deviation, is useful to know how to place those values on the normal bell curve appropriately. First, we know that the mean is going to be at the highest peak of the normal bell curve. In this case, the mean is 25. Next, I know that the standard deviation is 7. So I can subtract 7 from 25 to have 18. So I know the value for one standard deviation below the mean is 18. And when I add 7, the value for one standard deviation above is 32. Now where do I place those? Do I just move over just a little bit, or do I move a long ways over? Well, what we look for is we look for an inflection point on the normal bell curve. An inflection point is when the slope of a curve changes from increasing rapidly to increasing slowly, or like in reverse, decreasing slowly to decreasing rapidly. We're looking for the inflection point. And on this picture, the inflection point appears right about there, symmetrically on each side of the bell curve. So that's where I'm going to place my 32 and my 18, the values for one standard deviation below and above the mean. And as I look at that, this distance between the 18 and 25 and 25 and 32 is a little off. So I'm noticing that I need to place my 18 in a better location, which is more directly underneath that inflection point. Okay, now I know that my distance for one standard deviation from the mean is about that far. And so when I want to place another standard deviation on, I need to go about the same distance and say there's my second standard deviation, which is going to be 11, because 18 minus a standard deviation of 7 is 11. And I do that same distance one more time to know 3 standard deviations below the mean is 4, and it's at about that point. Moving up above, I add 7 onto 32, which is 39, and I add 7 onto 39, which is 46. And that's how I place my values on the normal bell curve.